I missed him again.
Shh! Gotcha! Darn. I'd never seen such an enormous fish. It was at least this big.
Are you sure? Maybe it was all a dream. How could you have found such a huge fish in a small pond?
Look, I'm telling you, I did.
Sure, you found the first freshwater shark in the world.
Oh, I'll tell you what. If you don't believe me, maybe you'll believe Jeannie. Come on, you'll see.
How are you, kids? Whee!
Tell her it's true, Jeannie. Go on, tell her I just missed catching an enormous fish. Tell her the truth now. I'm sure she'll believe you. Go on, tell her.
You thought the fish you were after was enormous, gigantic. But I'm sorry to say you were mistaken, Alex.
That's impossible.
It's not impossible because you were the victim of what we call an optical illusion.
An optical illusion?
Look here. You can't see the entire coin, only 3/4 of it. But as I pour water into the bowl, the coin seems to rise to the surface and you can see all of it.
Ah.
Because of light refraction, the light rays change direction, giving the impression that the object in the water moves and becomes larger.
Right, just like your fish.
Look, it was huge. Do you understand?
Then how come you let it slip through your fingers just like that? Whoop! Because of the light refraction, you not only thought it was bigger, but higher up as well, when in fact it was actually much smaller and much deeper. Do you see?
You win, I get it.
Light can play that sort of trick on us, and that's only one example. I think it's time we looked a little more closely at the subject of light. Let's go!
Oh, I'm so thirsty.
Hey, that's my canteen. Don't drink all my water, you hear?
I'm dying of thirst.
In that case, drink from your own canteen.
Hey, this is too much. Why don't we stop? What are you looking for?
An oasis. A place where there's water and vegetation where we can cool off and rest a bit. But I don't see any out there.
No, neither do I.
Watch it! Are you all right? Can you get up?
Oh, look! There's an oasis there!
Yes, I see it. Oh, at last!
Come on, we're almost
fantastic.
Oh, can't you go any faster?
He's so slow. Hurry up, will you?
Hey, do you think he's deaf?
No, just slow. Are we any closer?
Well, we ought to be.
I know, but it certainly doesn't look like it.
You're right, it doesn't. I don't get it.
But I do.
Tell us, Jeannie.
The oasis you see doesn't really exist.
Huh? But you can see it too.
It's a mirage.
A mirage? Really?
You mean that oasis isn't an oasis?
No, it isn't. A mirage is an optical illusion. The oasis is actually elsewhere.
Oh, that's great.
An optical illusion?
The lower layers of air are hotter than the layers above. The light rays are refracted and create a mirage. There are many different kinds of mirages. The most common are those we see in the desert. Because of the intensity of the sun's heat, distant objects are seen in reverse, exactly as if you were looking at a reflection in a lake. This phenomenon is not only visible in areas as hot as the Sahara Desert, but it can also be observed in polar regions. when the temperature at the water's surface is lower than the atmospheric temperature, creating a different kind of mirage. We see the reverse image of the ship on the horizon. According to the situation of the layers of hot and cold air, mirages can appear in different positions. Here, for example, we see a ship whose mirage seems to be going in the opposite direction. In high mountain areas, when you get close to the summit and there are thick clouds or heavy fog, the climber's shadow is reflected on the clouds. A halo of light forms around him. This phenomenon is caused by the existence of little drops of water, which make up the clouds as well as the fog.
Unbelievable.
You're right! Light phenomena are incredible!
They sure are, especially mirages.
Like when you think you're seeing water.
Huh, water?
I don't see any water.
But I'm sure you thought you did lots of times. Can you remember being in a car and thinking there was a puddle of water in front of you on the burning asphalt?
The mirage is an optical illusion. I can understand that. But does what you actually see exist elsewhere?
Yes.
In that case, Jeannie, how about taking us to a real oasis? We're counting on you.
Oh. I don't believe this. There's nothing here in the desert. No plants, no animals, nothing. I can see why it's called a desert. It's deserted.
But
we'll never get out alive. Oh! Ow! Oh!
Watch it, Alex!
Ah! Oh no, a snake!
You're afraid of snakes too, aren't you?
Of course not. How silly. But you see, there is life out in the desert. There are animals like, for example, scorpions and spiders. And reptiles too, such as lizards and snakes. But they usually come out in the early morning and at night, when it's nice and cool. I guess you must have woken that snake up.
Right. Oh, if only it would rain.
I think you're confusing mirages with miracles.
You had to insist on seeing an oasis. This is all your fault.
My fault? My fault? It's easy to say that now, but don't tell me you didn't want to see it too.
If I had only known. Anyway, let's hope night comes soon. At least it will be cool. Oh, what are we doing out here in this no man's land?
What time is it? Do you think it'll be night soon, Jeannie?
Hey, look over there, kids. Someone's coming.
Oh, maybe he can help us. Hey!
Hello, sir.
What do you want?
Nothing really. We were just wondering if you know what time it was.
Huh? What's he doing?
Ah, a sundial, I guess.
That must be it.
It is between 1 and 2 o'clock.
Oh, is that all?
Mr. Bedouin, where is the nearest oasis?
Yes, we're all out of water.
Turn your backs to the sun and walk as if you were walking on your own shadow for 3 or 4 hours and you'll find the oasis.
Do you know why shadows exist?
Well, because of the sunshine, right?
Right, but that's only part of the answer. Of course, we all know that the sun shines. But did you know that light always moves in a straight line? That's why, by looking at the shadow made by his stick, the old man was able to tell us the time of day. What's up ahead?
Really? The
Oh,
oasis?
fantastic!
The watering hole is dry.
Oh, I don't believe it! Oh,
I'm thirsty.
oh, water!
Oh, come on, stop your complaining. Look at what's on the way and listen.
It's rain!
A storm! Hooray!
It's great!
Oh, fabulous!
It's magic.
Pretty clever way to collect water. The storm's over already. It's beautiful.
The sun is so pretty.
Did you notice? The light always travels in a straight line. It's the same with an electric light bulb. To prove it, cut a little hole in a piece of cardboard. The pencil-like ray goes through the hole in a straight line.
Yes, you're right.
That's interesting.
It's exactly the same for all light rays, regardless of the source. Theater spotlights, for example. Or lighthouses. And even the rays of a flashlight. You must have seen or even played at making shadow animals. And you've seen movie projectors, I'm sure. Light is what we call rectilinear, and as you see, it can be put to many uses.
Look, a rainbow!
If you look closely, you'll see two rainbows instead of one.
I see it.
The one on the inside is the principal rainbow, the other is the secondary.
It's pretty.
Is there a connection between the rainbow and the fact that light is rectilinear, Jeannie?
Of course there is, but don't forget what I told you about light refraction when we were discussing mirages. Well, a rainbow is also caused by light refraction. The first accurate explanation of a rainbow was made by the French philosopher and scientist Descartes in 1637. You can see a rainbow just before or just after the rain, when the sky is full of drops of water. And if the sun shines, certain rays of light are reflected on these drops of water. Other rays pass through them, or are refracted on entering the water, then refracted again inside it, and once again as it leaves the drops of water. Sunlight consists of many colors, and each one follows a different path inside the drop of water and comes out separately. That's That's why a rainbow has 7 different colors.
But the order of the colors in the second is the reverse of the first.
Now that is a very clever observation, Alex. You're right, the colors are exactly opposite.
The red is on the inside.
And the violet is on the outside.
Why is that so, Jeannie?
The arrangement of the light through the suspended drops of water is exactly the same for both of the rainbows. What's different is the number of reflections in the drop. To form the principal rainbow, the rays are reflected only once inside the raindrop. The secondary rainbow is formed by rays which are reflected twice inside of it. And since the ray weakens by being reflected twice, the secondary rainbow is harder to see. By pulverizing a few drops of water, you can make your own rainbow. But you have to turn your back to the sun. If not, you'll never be able to see it. Look at this! The ray of light coming through the center of the carton reflects on the water contained in the rounded bottle, just as it does in a raindrop, and forms a circular rainbow. This 3-sided block of glass is called a prism. It allows us to study the movement of light. After having gone through the prism, the light breaks down into 7 colors.
Like in a rainbow.
Right, because just as in a raindrop, each color moves along a different angle.
Oh, it's so hot. Oh. Can I have your canteen? Mine's empty.
No, you can't. We've got to save what's left of our water.
Oh, I'm so hot.
How would you like to know why you're hotter than we are?
Yes, I would.
Because he's not in as good shape as we are, right?
That's not it.
Well, then tell us why.
It's simply because certain colors absorb the sunlight more easily than other colors, and therefore retain the heat. And of all colors, black is the most absorbent and retains the most heat. A dark color always heats up faster than a light one.
Just my luck.
That's why in the wintertime it's best to wear dark colors.
And in summertime, then it's best to wear white, since white doesn't absorb the light but reflects it instead.
Don't forget, light colors in summer to keep cool and dark colors in winter to keep warm. Have you got that?
Yes, I've got it, but right now I'm thirsty, you hear?
I think we understand that.
Ah!
What's wrong, Jeannie?
Ah! A snake! Ah!
Ah!
Hey, Jeannie, you said the snakes didn't scare you.
I'm not afraid. I'm not. Whatever gave you that idea? I can't wait for night to fall.
You mean you can't wait till it's cooler?
Not only that, but also so we can find our way back.
Don't tell me you've lost our way.
It's true, but if you don't want me to tell you, I won't.
Oh.
But why wait until nightfall, Jeannie?
Because of the stars. That's all you really need to find your direction. Throughout history, man has used the stars to orient him on land as well as on the sea. The sun during the day and the stars at night.
Yes, but how do they do it, Jeannie?
Well, let's imagine that we're aboard a ship and we're lost in the middle of the ocean. The captain uses the stars to determine his position. Don't forget that starlight also comes down in a straight line.
If that weren't true, I can just imagine the captain's face.
Oh, how will I get home?
We were wondering the same thing.
Sunlight, starlight, and moonlight are the best guides we have.
By the way, Jeannie, have you managed to find the right direction?
I think there should be a city behind one of those sand dunes. If my calculations are right, we should be coming to Saudi Arabia.
Look, there it is, the city! Oh, look, it's all lit up, too!
I was right! Hooray!
The trip was fantastic.
I was just getting used to riding on a camel, too.
Is that all?
Huh?
What about all the fascinating phenomena that light provides? You won't forget them.
We sure won't.
There are thousands of things to learn about light.
That's right, and light makes almost everything possible.
And it's full of surprises.
Right, and next time I see you, I'll show you some other fantastic things light can do.
Oh, great, Jeannie!
That'll be enlightening.
Okay, see you soon.
Bye.
Hello, I'm back, kids. Did you have a nice day here at home?
Yes! If Dad only knew where we had been today.